Okay, let's talk about matter. Matter is anything that has mass and occupies space, and we classify matter by composition. There are pure substances and there are mixtures. Pure substances are matter that have a fixed or definite composition. There's two different types of pure substances, elements and compounds. Elements are the simplest type of a pure substance. They're composed of only one type of material, and it's composed of atoms of those material. For example, aluminum in an aluminum can, silver, gold, iron. Compounds consist of atoms of two or more elements, always chemically combined in the same proportion. So for example, water and hydrogen peroxide, both are made of oxygen and hydrogen, but in water, there's two hydrogens and one oxygen in every molecule, and in hydrogen peroxide, there's two hydrogens and two oxygens in every molecule. Compounds can be broken down by chemical processes into their elements. So for example, with sodium chloride or table salt, we can break that down into sodium metal and chlorine gas, the elements that it's made out of. So let's just go through some examples. A silicon chip is an example of an element. Oxygen gas is an example of an element. Rust, Fe2O3, is an example of a compound. Methane, CH4, is an example of a compound. Helium gas is an example of an element. Sugar is an example of a compound. Lye is a compound. Sulfur is an element, and mercury is an element. Let's talk about mixtures now. Mixtures are two or more different substances that are physically mixed but not chemically combined. So one example is air, which is a mixture of mostly oxygen and nitrogen. Steel is iron, nickel, carbon, and chromium. Brass is zinc and copper. The proportions in mixtures are not constant and they can vary. So for example, sugar water, I can make sugar water with, let's say, 1 tablespoon of sugar in a cup of water, or a tablespoon of sugar in 2 liters of water. They're both sugar water, but the proportions are different. Okay, let's do some examples. So baking soda is a pure substance and it's a compound. Ice is a pure substance, it's a compound. A blueberry muffin is a mixture. Zinc is a pure substance, it's an element. Trimix in a scuba tank, which is oxygen, nitrogen, and helium, that's a mixture. A soda is a mixture. Propane is a pure substance, it's a compound. An iron nail is pure substance, it's an element. Salt substitute, KCl, is a pure substance, a compound. And a cheese sandwich is an example of a mixture. Let's talk about separating mixtures. We talked about how in compounds you can separate compounds into their elements using a chemical process, but for mixtures we use physical, not chemical processes. So for example, coins can be separated by size, or iron mixed with sand can be separated with a magnet. Here's some other examples of types of separation. Filtration is one type. Filtration is mainly used to separate solids from liquids. And here's a picture of vacuum filtration. So what we do if we have a mixture of a solid and a liquid, we would pour it into the funnel on top and it would filter out the liquid into the bottom and our solid would stay in the funnel on top. There's a piece of paper lining the funnel to catch the solid. Usually we do filtration when we're interested in the solid. Separating liquids is a little bit different. One type of liquid separation is chromatography. Chromatography separates liquids from each other as they travel at different rates on a chromatography medium. And chromatography separates liquids by polarity, but also can separate liquid molecules by size. So here on the left, this is called column chromatography. And you can see all the different colored bands in the column. Those are different liquid molecules. So we would pour it on the column, we pour some solvent liquid over it, and they travel at different rates down the column, and we can actually capture the different liquids in a little flask underneath the column. Then on the right, this is paper chromatography, which you may have done in a chemistry class or a biology class. Same idea, right? It separates the liquid molecules in the same kind of way, but instead of on a column, it's on paper. And usually we use paper chromatography not to isolate different molecules, but just to see how we might separate them. And then we can apply those principles to the column. Another type of liquid separation is distillation. We can separate liquids that have different boiling points using distillation. So we'd have a flask that we put heat underneath to boil. And then the liquid that with the lower boiling point vaporizes first. So it goes up the flask, and then it falls into a condenser where we have cold water flowing. So it turns the gas back into a liquid, and it drops into a flask lower down. And again, that receiving flask collects the liquid with the lower boiling point. So there's different types of mixtures. Mixtures can be further classified as homogeneous or heterogeneous. Homogeneous mixtures are also called solutions. The composition is uniform throughout the sample, for example, air or seawater. Heterogeneous mixtures, the composition is not uniform throughout the sample. So some examples of this are oil on the surface of water or a chocolate chip cookie. So let's do some examples. So non-fat milk is a homogeneous mixture. Peanut butter sandwich is heterogeneous. Cranberry juice is homogeneous. Tea is also homogeneous. Tea with ice and lemon slices would be heterogeneous. Vegetable soup is heterogeneous, Okay, let's talk about states and properties of matter. So states of matter, there's one of three physical forms that matter exists in on Earth. One state is solid, and solids have a definite shape and volume. Liquids have a definite volume, but not a definite shape. They take the shape of the container. Gas doesn't have a definite shape or volume. It takes the shape and volume of its container. Okay, let's talk about physical properties. Physical properties are characteristics that can be observed or measured without affecting the identity of the substance. So some examples are shape, color, melting and boiling point, and the physical state of the matter. So we have copper pans here. These are copper in color. They're shiny. They're shaped like a pan. Those are all physical properties of these copper pans. Physical changes are changes in state, size, or appearance, but the composition stays the same. So for example, water to ice or water vapor, dissolving salt in water. When we dissolve salt in water, we can separate them by evaporating the water, but we still have salt in water. Okay, let's talk about chemical properties and changes. These describe the ability of a substance to change into a new substance. So when a substance is converted into one or more new substances, a chemical change has occurred. So one example of this is rusting of metal, such as iron. So when iron reacts with oxygen in the air, it forms iron 3 oxide, which is rust. That's a chemical change. We no longer have just iron and just oxygen. Another example is wood burning and producing heat, ashes, carbon dioxide, and water vapor. Okay, let's look at some examples. Pie dough is rolled into thin pieces for a crust. That's a physical change. A silver pin tarnishes in the air. It's a chemical change. A tree is cut into boards. That's physical. Food is digested. That's chemical. And a chocolate bar melts. That's physical. Here's some more examples. These are physical or chemical properties of zirconium. So zirconium melts at 1,852 degrees Celsius. It's a physical property. It's resistant to corrosion. That's a chemical property. It has a grayish-white color. That's physical. It ignites spontaneously in air when finely divided. That's chemical. And finally, it's a shiny metal. That's a physical property.